Welcome to the ET380 video on the Class C Amplifier Lab. Here's a schematic that we built in Multisim, and we have our tank circuit, and this amplifier will double the voltage, input voltage, based on this resonant circuit, and we'll take a look at it. Okay, let's review the Class C amplifiers used for RF signals only. The tank circuit in the output. Output is 2 times the supply voltage. Only works with one frequency. The tank circuit frequency must match the input frequency in order to resonate. And it has a very high efficiency, about 95 to 98%. Okay, so let's calculate our center frequency. This is the frequency we need to set on our function generator in order to get our circuit to resonate. All right, so let's go ahead and here's the formula, and here are the circuit values, and let's go through the calculation. On clear, 2 times pi, second, x to the second, which is going to get us square root. Then we have 1 second EE minus 3 for milli times 0.01 second EE minus 6 for micro. Let's close the parentheses and do an equal. And then we're going to inverse equals, and we should come up with 50 kilohertz. Okay, here we are back at our Multisim circuit that we built in my last video. Let's go ahead and start it. First thing we need to do is set our function generator. I wasn't able to get it to work at the 1.5, so let's just let's try 4. And let's go to frequency, and we're going to set it at 50, our target. Good, and we'll move this guy over, and let's open up our scope. And let's go ahead and see what we got here. So let's just go ahead and measure. Turn on channel 2, go back to measure. So we're going to, we don't need the frequency on the input, so let's go ahead and change this to channel 2. Take a look at how much voltage we get back, and let's turn this frequency on for channel 2. Good. And let's see if that is, we actually got it resonating right at 50. Let's see if that's the maximum. Wow, pretty interesting. It, oops, let's get back up. It looks like 50 is right where it resonates. So let's spread this out a smidge. Okay, so we have 4 volts in, we have 38.4, 8 out, still at 50 kilohertz. Let's go ahead and do a single sequence, and that looks good. Okay, here's a close-up for our oscilloscope, and we might be a little clipped here, but that's okay. We have 4 volts in, and we have 30.8 out. Looks good. Okay, we're back at Multisim. Let's go ahead and check and see if it works as a frequency doubler. So what we're going to do is divide our frequency in half. Let's start it. Ignore anything that any of our error correction, it'll lock it up forever. So that's looking good. So let's drop this down to 25. And let's see, is that the maximum? Actually looking pretty good. So let's take a look at All right, so let's go ahead and change this to channel 1, frequency, and frequency, and let's go ahead and see what our peak to peak is. Okay, so now we have 4 volts in. We don't have enough of our signal to get a frequency value. Now we do. Like I say, ignore that, otherwise we'll waste a lot of time. Restart it, and let's go ahead and do a Siegel sequence and see what we got here. 4 volts, 25 kilohertz in. We maintained our 50 kilohertz out, and we have 30 volts out. Good. Okay, here's a close-up of our circuit for a doubler, and our input frequency is 25 and our output is 50, so it is working as a doubler, and we're getting about 30 volts out. It's perfect. Okay, we're back in Multisim, and let's go ahead and restart this and redo it, and we're going to see if we can make a tripler out of this. So our frequency would be 16.67. Oops. And we can move it over a digit. Move it back over where I drop that down to 16. 16.60. I want to call that good, so let's lock it. So right now we have, and we're getting 50 kilohertz out, and we're getting around 30 volts out. Perfect. Okay, here's a close-up of our oscilloscope as a tripler. We put in 16.6, and we're getting 50 out and at 30 volts, so it's working very well. Perfect.